Class example 1.2.5. At Fitz Flooring, the opalescent arabesque style of tiles measure 20 centimeters by 36 centimeters, assuming that rectangles cannot be cut. A, what is the style length of the smallest square that could be tiled? And B, who comes up with the name for styles of tiles anyway? This is a lot of big words, a lot of information. We got to figure out where to start. So the first thing I'm going to do is I'm going to figure out what does an opalescent arabescent style of tile that measures 20 centimeters by 30 centimeters look like. So if I can see that it's a common shape we probably have seen before. This one looks pretty intricate and interesting. I really like the color. But I can see I've got a nice rectangle here that's measuring 20 centimeters by 36 centimeters. Okay. So this is the nice rectangle that I could purchase at the store. I'm not wanting to cut these things, so I don't want to take this section and let's say cut that off and do this. Instead, what I'm going to do is I'm only going to keep the actual nice rectangles I have themselves and see if I can actually get a nice square. And what is that smallest square that I can tile? So what I'm really trying to do is I'm trying to take a 20 by 36 tile like this. And I maybe put another tile next to it. Maybe I'm going to put another tile up here. Ooh, I'm going to go with another tile over here. And although this is a 2 by 2 rectangular grid, you could say, well, that's 2 tiles wide and 2 tiles long. We know 20 plus 20 is actually only 40. And we know 36 plus 36 is 72. So this is not a true square. Okay. So we're getting closer. We know we can't cut things. We know kind of what the shape looks like. Let's see what else we can figure out here. Now, in section 1.2, we have looked at prime numbers. We've looked at the numbers themselves. We've also looked at factor trees. We've looked at greatest common factors. We've also looked at lowest common multiples. So if I read this question, we know we can't cut things, so I kind of got the first half of this done. I know I'm not cutting anything. I know what they look like. I know what they are. I see what is the side length of the smallest square that could possibly be tiled. So when I see the word smallest, I'm thinking lowest. I'm thinking the lowest common multiple, but let's just double check when we're talking about the common part. Now, if I'm to try and do a square, I know that we could tile a 20 by 36 by placing a nice one down, nice tile down. I'm going to place another one. Look at nice, drew my line for me. And so I could go ahead and tile some more. You know, you kind of get the point, right? And so I could keep going this way and I could keep going this way. But what I really want is I want to know how many of these tiles do I have to place this direction in order to get to a side length that's going to be the same as this side length, because we know we want it to be a square. So how many do I need to go this direction and how many do I need to go to this direction for us to find a common number? So what we're going to do is we're going to find the lowest common multiple between 20 and 36 and put this into because the multiples of 20 are quite easy to list. I'm actually just going to go ahead and do that. I know 20, 40, 60, 80, 100, and I could keep going. I'm going to go up to 200. Okay. Now 36 is a tiny little bit more difficult, but not that bad. We know 36, if I double 36, I get to 72. If I triple 36, I get to 108. And I can add 36 or multiply it by any number. Ooh, sweet. I can stop right here because I actually got to 180 already. So I know that the lowest common multiple between 20 and 36 happens to equal to 180. Let's try and put that into the context of our problem. Okay, so if I had 1, 2, 3, 4, 5, 6, 7, 8, 9 tiles, let's just go 1, 2, 3, 7, 8, 9 tiles this direction, each with a nice 20 at the bottom. And I could keep going, you know that that's 20. I get 20 times 9 is 180. So this side length would equal to 180. Then, of course, I'm going to fill those tiles in with 1, 2, 3, 4, 5 tiles going up this way. 2, 3, 4, 5. Now, of course, we know that that's really one of these tiles, and I didn't draw the full thing in because you kind of got the idea when we were looking at this problem before. Okay, so really, I do now know this side is 5 times 36, and 5 times 36 also happens to equal to 180. So I know the smallest possible square with no cuts on our actual tiles will be 180 centimeters as one of its side lengths.